Hello everyone. In this video I want to talk about the three authentication methods we have in Azure Kubernetes Service. I think this topic is quite overlooked, although it's very crucial for the security of your Kubernetes cluster. So let's have a look at the three different modes we have, and throughout this video I'm going to show you how to implement all three of them, and I'm going to tell you the advantages, the disadvantages, and which authentication mode you should use. So the first authentication mode we have is local account with Kubernetes RBAC. This is the default option, and this is the worst option you have. And I think this is quite a problem because all the documentation you see online from Microsoft, but also from third-party vendors, tell you just use the default implementation, and then you end up with an insecure cluster. The next option we have is Microsoft Entra ID Authentication with Kubernetes RBAC. This is a mix of Azure and Kubernetes. So you do the authentication with Azure. This means you have to log in with your Entra user, and then you do the authorization with Kubernetes. This means inside of Kubernetes, you can define role bindings and roles, and these role bindings define what permissions you have inside the cluster. And the third option, the best option, is the Microsoft Entra authentication with Azure RBAC. And in this option, we use Azure to manage the authentication and the authorization. And with this, let's take a look at the demo. Before I get started, let's define three variables. The variables are the name for our Kubernetes cluster, the location, and the name for the resource group. Next up, we're going to create the resource group, and we provide the name we just defined and the location, in this case, Canada Central, and then we deploy our Kubernetes cluster. And as I said in the beginning, the local authentication is the default mode. This means if you don't configure anything, AKS will automatically take the local authentication. And to create the Kubernetes cluster, we just use the AKS create command. We provide a name and a resource group name. Our AKS cluster has been created, and now we can access the cluster. The first thing we have to do is download the credentials and save them in the kubeconfig file. And to do this, we use the AKS get credentials command. We provide the name of our AKS cluster, and then the override existing parameter to override any config that already may exist. And with this, we should be able to access our cluster now. So the first thing I'm going to do is just kubectl get ns for namespaces. And there we can see we can access our cluster. We see 4 namespaces, and they have been created 12 minutes ago. Now let's create a new namespace. So we use kubectl create namespace and provide a name. So let's provide the name read. Then I like to set the current context, so I don't have to provide the namespace I want to use all the time. So I'm gonna configure the namespace to be read. And then we're just going to run an nginx image just to test if everything is working. And we can see we have enough permissions to create the namespace, to create the pod. And if we wait a couple seconds, then we should be able to see the pod running with kubectl get pods. This works and everything is great. And now let's have a look at the access token we just downloaded, or downloaded the first step in our kubeconfig file. So if you open our kubeconfig file, that's in the home directory in the kube folder, and the name of the file is config. There we can see everything we need to access our cluster. And this also shows the biggest problem of the authentication mode, where we use the local accounts and don't have any authentication or authorization. So the the token and all the information for the cluster is stored in clear text here inside this kubeconfig file. So for example, here we have the URL to our server, and if we scroll down a bit, we have here the access token and everything we need to access the cluster. And if you scroll over there, there's the entire token. And if I leave my cluster running and you see this video, then you are able to access my cluster by just copying this token. And this is a major security problem because you don't know who gets access to this token. Maybe your computer has a problem, so you give it to your IT department for maintenance. Maybe you have the file open while you sit at a Starbucks and somebody takes a picture of it. There are endless options. And also, we didn't have to log in. So we don't know which user is currently accessing the cluster. It's always the admin user. And to showcase how easy it is to take over this cluster, I'm going to copy the entire kubeconfig file, and then I open my WSL2. So that's a complete fresh machine, and we simulate that I'm an attacker, I stole the access token, and now I want to access the Kubernetes cluster. And all we have to do is we open the kubeconfig file with a text editor. Then we quickly provide the name for sudo. And now I'm going to paste the token inside the kubeconfig file. And then we're saving this file. And if everything worked as expected, I should have access to the cluster now. So let's test it. And we do again kubectl get namespaces. And we see all the namespaces this cluster has. And I wasn't asked to log in, to authenticate myself somehow. I just have full access. And to prove that I have full access, let's delete the namespace we have created before. So we use kubectl create namespace, then we provide the name, then we wait a couple seconds and the namespace will be deleted. So I as an attacker have full control over the cluster, and the admin of the cluster doesn't even know about it because there's no alerting or monitoring because I don't have a specific user for it. And there's also no auditing because everyone is using the same user. And you could set up the Kubernetes authentication, but it's very complicated because you have to create different service accounts, you have to match tokens, get the tokens to the users, and it's so complicated that I have to admit I've never done it before because I'm using the cloud to have a managed cluster, so I don't want to take care of all of this. And therefore, I think even if we have the option, it's not really feasible that we use it. Fortunately, we have Azure, and therefore we have two additional authentication methods, and both are more secure and easier to implement. So the next one we are looking at is the Entra ID Authentication with the Kubernetes RBAC. So if you go back to our original terminal, let's clear this up. Then we're going to define a couple variables. And as you can see, we are defining more than we defined for the first authentication. So we start up with the name for our Kubernetes cluster, but then we have to provide a group ID for the admins. And we are going to use this group ID to give every member inside this group the admin role when we create the cluster. In theory, you could use a user ID, so you won't get any error or anything, but your user won't be able to access the cluster afterwards. So it has to be a group. Then we provide the group ID of a second group. That's a group we're going to use to test the read access. And then at the end, again, the location and the resource group name. And with this, let's create a new resource group. And then we're going to deploy our Kubernetes cluster. With the resource group created, we can use again the AKS create command to deploy our Kubernetes cluster. but this time we provide the name and the resource group, but we also use the enable AAD command or flag, and then we provide the name, the ID to the group, which should be the admin of the cluster. And there you can see it still says AAD, which means Azure Active Directory, which has been renamed, I think 2 years ago to Entra, but the CLI hasn't been renamed yet. And that's a thing all over Azure. So if you see Azure Active Directory or AAD, always remember this is called Entra now. The deployment of the AKS cluster took a couple minutes, and now we can download the config. And to do this, we use the AC AKS get credentials command. We provide the name of the resource group and the name of the cluster. And that's the same thing we did in the first authentication mode, but now we have to do an additional command, and that's the kube login convert kubeconfig -l Azure CLI. And with this command, we tell the kubectl to use the Azure CLI for the authentication. So if you're not logged in, you might be asked to log in with your Entra user. And now we can test the access to our Kubernetes cluster. So again, let's do a kubectl get namespace to see if we have access, if everything is working. And there we can see the namespaces has been created 8 minutes ago. And like in the first example, let's create a new namespace with kubectl create namespace and the name read. Then I set the context of my config again to the read namespace, so I don't have to provide the name all the time. Then let's start a new pod of nginx. The reason why I'm using nginx, it's a fairly small image, it's easy to run, and it's just to test if everything is working. And then we check if the pod is running. And there we can see everything is working as expected. And this works because my user is in the admin group we used to create the cluster. But not everyone should have admin access. For example, on a production environment, the developers might only need read access. And to do this, we have to use the Kubernetes RBAC system. And therefore, we have roles and role bindings. And with this role binding, we combine a role, for example, the reader role, with a user. Let's take a look at the configuration of the role and the role binding. So here we have the role. So that's a basic Kubernetes resource of kind role. And you can see it's on one side a bit complicated. On the other side, it's very versatile and you can configure exactly what you need. For example, here under the resources, we can say what resources, for example, a pod, a service, or further back here, a secret. And then we can configure what verb we want to allow for these. So we have here the get, list, and watch. And as you can see, we don't have a create or a delete because a reader should only read stuff and not create it or delete it. If you want to have a reader role that can only display pods and services, for example, then you could delete everything at the end here. And now this role is only allowed to do get, list, and watch on pods and services. But for now, let's keep everything as it is. And if we go down the list, we can also see other configurations, and there you can configure whatever you need. And again, it's powerful, but also complicated. So it's an up and down. And what's important, that we provide the name as view. So I think a better name would be reader. So let's rename this. And now we go to the role binding. So we combine the user we want to assign with this role we had just created. And here we have another Kubernetes object of kind role binding. And then we configure who we want to assign this role binding to. So in this type, it's a group. if we assign it to a user, we would have to change this to user. Then we provide the Entra ID of our group and in what namespace we want to apply this. So in this case, we are going to apply it only in the read namespace. And then in the role reference, we are referencing the role we just created. And here again, we have a kind. In Kubernetes, we have two different kinds with role that's scoped on a namespace level. And then with cluster role, which is for the entire cluster. But since we want this role only accessing our read namespace, we are going to use the role. Then we provide the name of the role. As I just changed it to reader, I have to update it here to reader 2. Otherwise the binding won't work. And that's it. Now we can apply both files and then we can test if the members of this Entra group can only access the read namespace. So let's go back to our terminal. And then we just use a kubectl apply command and provide the path to the file. So in this case, the reader role first. And then we do the same for the reader role binding. And the last thing we have to configure is to assign the Azure Kubernetes Server Cluster user role to the ID to the group we just assigned the reader role. And before we do this, I forgot to create an additional variable. So let's do this now. That's just a variable for my subscription ID. And now we can use the AC role assignment create command to assign the role. So we're using the Azure Kubernetes Server Cluster user role. This role allows the users to download the kubeconfig and so they can access our Kubernetes cluster. Then we provide the ID of the group and then the scope is our AKS cluster. And if you try this yourself, as always, the entire code will be on GitHub, but here you only have to provide the variables and you can just copy and paste the entire command. This should only take 1 or 2 seconds. And after the role binding has been created, we can log out and log in with the reader user. Even though the role binding only takes a couple seconds, it might take a couple minutes for Azure to sync all the permissions. So if you log in with a different user and you get a permission denied or unauthorized error message, just wait a couple minutes and then it should work. So before we are logging in with the other user, I'm just going to log out of my admin user. So I use AC logout. And then I'm also using AC account clear just to delete all the subscriptions that might have been cached. And then I'm also going to my kubeconfig file and delete the kubeconfig. Again, this is just to make sure that I don't have anything laying around from before, which may cause an error. Usually we only use one user, and so we will never run into this problem. With everything logged out and cache is deleted, we now can log in again with AC login. But this time I'm using the user of the reader group. And I've prepared here a user, the demo user, and this time I'm picking this user. After the login, we can then download the kubeconfig file. It's the same command as before, the AC AKS get credentials. And then we also use the kube login convert command to tell the kubectl to use the Azure CLI for the authentication. And now let's test if we have access to our Kubernetes cluster. So we do a kubectl get namespace. And here I would expect an error message because this user should only have read access to the read namespace. And here you can see we have an error message. And the error message says namespace is forbidden for user demo user. This is exactly what we expected and what we wanted. And now let's take a look if we can access everything that's inside the read namespace. This should work. So use kubectl get all and the read namespace. And here we can see it worked, but it looks like it didn't work. So let's clean up this window and execute the command again. And as we can see here, we can see the namespace. So this worked, but we also got two error messages that we are not allowed to see the replication controllers and the horizontal pod autoscalers. This means that we didn't configure everything in the read role. And this is something you might want to do. For example, I as a developer only have to see the pods, but I don't have to see the autoscaler configuration. And with this, with the Kubernetes RBAC, you can exactly say what resources are allowed and which resources are not allowed. And lastly, we're going to delete the pod that's running, or at least we try to. And here we also get an error message. So it's the same error message as before. It's forbidden for the demo user, and we cannot delete the resource pods because our user only has the read access, and that's exactly what we wanted. Here we have seen that we have two different users, one admin user and one user that only has certain read access to one namespace. But we've also seen that it's kind of complicated to set this up. Like we set it up for one user or one group for one namespace. So if you have a bigger cluster, it can be quite. Also, we don't see it from Azure. So if you want to see who has access, we have to log in as an admin user into the Kubernetes cluster. Then we have to get the role binding. Then we have to check the ID of the group or user, go back to Entra and find out who this group or user is. So it can be quite complicated to audit what's going on. And therefore, we have a third option for the authentication, the Azure Entra Authentication with Azure RBAC. And with this approach, we can see everything in Azure. And let's take a look how this works. Let's clean this up. And like in the other demos, we are defining a couple variables again. It's a new name for a Kubernetes cluster, the location, a new resource group name, and our subscription ID. Now let's create a new resource group with the name and the location we just configured. And now we are going to deploy our AKS cluster with Azure Entra ID Authentication and Azure RBAC. And to do this, we provide a name and resource group as always, but this time we also provide the enable AAD parameter. So this tells AKS to use Entra ID for the authentication. And then we provide the enable Azure RBAC parameter to tell AKS to also use Azure RBAC and not the Kubernetes RBAC. And AAD stands for Azure Active Directory. And this has been renamed, I think, 2 years ago to Entra ID, but the CLI hasn't been updated yet. And you will also find in the documentation quite often still Azure Active Directory. So if you see this, just remember that this is called Entra ID now. Let's start the deployment, and it's going to take between 5 and 10 minutes, and then our cluster should be deployed. The deployment is finished, but this time, unlike with the Entra ID authentication and Kubernetes RBAC, we didn't provide an admin group. So we have to give our user or admin group permission to access the Kubernetes cluster. And we can do this in the Azure portal or in the Azure CLI. And just to show you, let's switch to the Azure portal. And there we can see all the resource groups we created today. And we want to access the Azure RBAC one. And there we can see our Kubernetes cluster. Then if you go to access control on the left, we can add a new role assignment. There we search for Kubernetes. And here you can see all the roles for Kubernetes that are built in. And we want to use the Azure Kubernetes Service RBAC cluster admin role. So that's the second one here. And with this role, we can do everything in the cluster. Then we select my user or my group. So for now, I'm just selecting my user and then assign my user this role. This only takes a couple seconds, but it might take a couple minutes until the synchronization in Azure worked. So let's wait a couple minutes and then we test the access to the cluster. Thanks to the magic of editing, a couple minutes have passed and now we can test the access to the Kubernetes cluster. So first we have to download the kubeconfig, and again we use the AKS get credentials command, and then we use the kube login convert command to tell the kubectl to use the Azure CLI for the authentication. And now let's see if we have access to the cluster. So again, I like to do a kubectl get namespace just to see if I have access. And there we can see we have our namespaces and everything seemed to work. Now let's create a new namespace, the kubectl create namespace read. And as before, I set my context to this read namespace so I don't have to type it all the time. I create a new pod, the nginx pod. Should only take a couple seconds for it to start. And then we check if the pod is running. And there you can see it's running. So we could create a new namespace, create a pod, read all the namespaces. So it seems that I have admin access to the cluster. And now we want to give the demo user access to only this namespace we just created. And in the second approach with the Kubernetes RBAC, we had to create a new role, set all the permissions, do a role binding, and it was quite complicated. And with Azure, we have the option to use the Azure RBAC in the Azure portal or via Azure CLI. The only downside is we can only use the Azure portal if we want to give access to the entire cluster. For example, if our user should have read access on the entire cluster, then we can use the portal. But the portal is good for learning, but not great for operations. For operations, in a real world project, the CLI is way better anyways. And so I'm showing you how to use the CLI. And to do this, we use the AC role assignment create command. Then what role we want to provide. In this case, the Azure Kubernetes Service RBAC reader role. This means this role can only read the scope we provide. Then the assignee is the group ID of our reader. And the scope is going down to our Kubernetes cluster, but then even further. Like here you can see we provide namespaces and what namespace. So the name is read. And with this command, we configure that this entire group has only read access on the read namespace. And saying so many times read makes me realize that next time I should provide a better name for my namespaces. But for now, we have to do one more role assignment. And even though the users have read access now, they don't have the permission to download the kubeconfig file. So we have to give them the Azure Kubernetes Service Cluster user role. And again, we provide the ID of the group. And this time the scope is for the Kubernetes cluster. Now with everything set up, we can test if our demo user only has access to the read namespace. So we can log out of the admin account with AC logout. Then I also do an AC account clear, just to make sure that no subscriptions are cached. Then I'm also deleting my kubeconfig file just to make sure that there's nothing left over that could cause any errors. And then we can log in with the demo user. So use AC login. Then we select this time the demo user. And again, like before, we can download the kubeconfig now. And we use kube login to use the Azure CLI for the authentication. And now let's test our access to the cluster. Let's do a kubectl get namespace, and we should get an error message this time. And as expected, we get namespace forbidden for user demo user. Now let's see if we have access to the read namespace. So we do a kubectl get all for the namespace read. And this time we shouldn't get any error messages, and exactly here with our pod running and no error messages. This means we have access to every resource inside this namespace. And if we try to delete this pod, so delete pod nginx in the namespace read, we should also get an error message. And there's the error message already. And the last thing I want to show you is the role assignment in the Azure portal. So if you go back to the Azure portal and we go to access control, then the role assignments, and here you can see all the role assignments that my Kubernetes cluster has. So I have here a group with all my admins, then I have my user with the owner permission. And if you scroll down, we have the Azure Kubernetes Service RBAC cluster admin. That's the role we gave my user at the beginning to access the cluster. And then we have the Azure Kubernetes Service cluster user role, which we provided to the group so they have the permission to download the kubeconfig file. But we don't see anything about the permission of the group for the namespace. And this is what I said before. We only see permissions for the entire cluster here. So if you want to see the permissions for the cluster and for each namespace, then you have to use the Azure CLI. And we have also seen that Azure has already several built-in Azure Kubernetes roles, which you could use. For example, the admin, a reader, a writer. But if you need a specific role, then you can always use custom roles, and you can set exactly the permissions you need. If you're interested in this and want me to make a video how to set up your custom role and give permissions to Kubernetes resources, let me know in the comments and I can make a video about it. And for now, let's recap what we looked at today and summarize the free authentication modes we have available in AKS. Let's recap all the free authentication modes we have in AKS. The first one, as we have seen, is local accounts with Kubernetes RBAC. And in this mode, we don't have a link between Microsoft Entra or Azure and Kubernetes. And if you want to do authentication, you can do this with the built-in Kubernetes tools. But I have to admit, this is quite complicated and I've never done it myself. But if you're interested, I put a link to the documentation. And as always, I'll put this presentation on my GitHub. This authentication mode is only recommended if none of the users are in your Entra. But I've never came across this use case because you can easily invite even external users to your Entra, and so you will always have them in your Entra. Another problem is that the user management can be really challenging because you don't have any link between your user in Entra and Kubernetes, and you use service tokens, and that's another reason why you shouldn't use it. And the third reason why it's not recommended to use this mode is because the local accounts provide a security risk. So it's really hard to audit. You don't know who is doing what, and this user often have way too many permissions. And the last reason why you shouldn't use it is because the access token is stored unencrypted in your kubeconfig file, as we have seen in the demo today. Then the next authentication mode, which is better but still not great in my opinion, is the Entra ID authentication with Kubernetes RBAC. So as we've seen today, we use the authentication via Microsoft Entra. This means we have to log in with our Entra user, and then we do the authorization with the Kubernetes RBAC. This means Kubernetes checks its role bindings, what permissions we have. The administrator of our Kubernetes cluster can configure the role binding between Kubernetes role and the Entra user, and then the Kubernetes admin also has to give the Azure Kubernetes Service cluster user role to the group or the user that should access the cluster. And with this Azure role, the group or user can download the kubeconfig file. This approach is easier to manage than the local accounts because we at least have Azure users or group. But the downside is that we only use IDs. So we have to look up the IDs in Entra to see what user or what group we are managing. The only recommended use case for this approach is if you want to have a portable cluster. This means you want to have all your role bindings inside the cluster, and even if they point to an Entra user or group, you can still port them somewhere else and then just update the ID of the role binding. I've never encountered this authentication method in a real world project, but we have the option to do this, and it's definitely more secure than the local accounts. As I just said, the problem is that we're using IDs. This means that the auditing is not really easy because we always have to look up the ID, figure out what user or what group has access to the cluster, and then we can see what they did. And then the last and best authentication option is the Entra ID authentication with Azure RBAC. And with this authentication option, we only use Azure to manage the authentication and authorization. This means we use Azure RBAC to give permissions to the whole cluster or to only namespaces, as we also have seen in the demo today. And since this is the best way, that's also what Microsoft recommends you to do, because it's the easiest to manage, because you can see everything in Azure, and it's also the most secure way to access and manage the cluster. And as with the other approaches, or at least the second approach, the administrator of the cluster has to give the Azure Kubernetes Server cluster user role to the users or groups that want to access the cluster so they can download the kubeconfig file. And as you've seen today in the demo, you can give permissions in the Azure portal for the entire cluster. But if you want to give permissions for only namespaces, then you have to use the Azure CLI. That's everything I have today for the authentication options we have in AKS. And I'm curious to hear, how are you managing your authentication and the security of your cluster in general? So please write a comment, let me know. And if you're interested in more AKS and Kubernetes security topics, I plan to release more videos about AKS security, how to manage them. So subscribe and stay tuned for the next videos.